Welcome to our lesson about applying the K-factor. In this lesson, we're going to learn how these formulas work in SolidWorks. Let's start with a new sketch. Let's right-click on the front plane, New Sketch. Now activate the Line tool. We'll place a line about here. Smart Dimension. It's going to be 5 millimeters, except by 5 millimeters. Okay. Let me zoom in a bit and reposition my dimensions. And let's exit the sketch. Go to the Sheet Metal tab and activate the Base Flange tool. Let's take a front view. Here we're going to use a 1 millimeter thickness, a 1 millimeter bend radius, a K-factor of 0.5. Let's apply the formula that we learned in our previous lesson. Let me just pull it up here. BA, or bend allowance, equals 2 pi multiplied by the bend angle, which is 90 degrees in our case, multiplied by the sum of the bend radius, which is 1 millimeters. And by the way, the bend radius is always the inside radius, plus the K-factor multiplied by the thickness. In our case, the K-factor is 0.5 and the thickness is 1 millimeter. We divide all of this by 360 degrees. As a result, we end up with a bend allowance of 2.36 millimeters. Let's go ahead and measure our actual part to make sure this lines up. By the way, in order to see the bend region, right-click and select Edit Feature. In the Property Manager, uncheck Merge Faces, and let's accept and cancel out of the tool. Let's right-click now and unsuppress the Flatten feature. Now we're going to go to the Evaluate tab, activate the Measure tool, and let's take a measurement. As a result, we've got 2.36 millimeters, as our formula indicated. Now what about the total length of this part? Let's take a measurement. Let's right-click and clear the current selections from the Measure tool. Our distance is 10.36 millimeters. Let's see how SolidWorks calculates this. Close the Measure tool and expand the Base Flange branch. Unsuppress the sketch. Now let's right-click on the Base Flange, Edit Feature. The length of the Flatten feature that we just measured a moment ago equals the sum of the first length, L1, and the second length, L2, which in our case are both 5 millimeters. So, the sum of L1 plus L2 minus 2 times the bend radius plus the bend allowance. As a result, we get the length of the flattened part. The total is 10.36 millimeters, just as we measured a moment ago. One more thing here, let's check the reverse direction checkbox under Sheet Metal Parameters. The part, instead of being created outside the sketch, was created inside the sketch. As a result, the total length of the part changes as well. Let's see how SolidWorks made this calculation in this instance. We take the total length of the flattened part. That's the sum of L1 plus L2, which are both 5 millimeters in our model, minus 2 times the radius, which is 1 millimeter in our case, minus 2 times the thickness, and the thickness is also 1 millimeter as well, plus the bend allowance. As a result, the total length of the flattened pattern is 8.36 millimeters. Let's go ahead and confirm by measuring. Let's accept and OK again to exit the tool. Activate the Measure tool. Take our measurement. As expected, the total length of the flattened part is 8.36 millimeters. Let's look at the bend allowance region. This stays at 2.36 millimeters. And this concludes our lesson on applying the K factor.